So the objective of the lesson is to basically understand how to solve the equations using the general like unit circle method and using the general algorithm of like using calculator. So the first thing is that you are suppose let's say we have been given sine x equals to half, and you are solving for what x values I can plug in between 0 to 180 here such that my answer is coming to half. Now for such questions what you do is like in order to solve you need to remember the your basic unit circle rule. So when you look at the basic unit circle rule here, now we have the first is ASTC. So the steps are locating the quadrant, locating the quadrant. So what quadrant your angle might lie in? Okay, so the first step is locate the particular quadrant where you think is that sin x ratio is positive half. Now I can see that the first quadrant and the second quadrant sin is positive. So here and here sin x is positive. So in this case, you notice that okay, this is a possible position where sin x is half, and this is a possible position where sin x is half. Now what you're gonna do is that you first find out this base angle using a calculator. Now, since if it is sine half, it is very easy to say okay, the base angle for this is sine inverse of half, which is equals to 30 degrees. So I can find out the base angle on calculus, which is 30 degrees. So this angle is also 30 degrees. Now, once you locate the angles, the positions, then you measure the final angle between the angle ratio that they have given. So let's say the angle ratio is between 0 to 180. So we're going to take the first angle, which is obviously the angle, each and every angle is measured from the positive direction of x-axis. This is the reference axis. So the angle will be, the first angle will be 30 degrees. The next angle will be 150 degrees. Because this angle, if I go back and write down, this is 150 degrees. So these are the two possible angles for which sine x is half. Now, what I can do is I can ask you another question that, okay, solve for where sine x by, let's say, or sine, let's say, sine 2x, let's say sine 2x is equals to half, where x is between 0 to 360. Let's say this is the range of the x values has been given. I need to find out now what values of x should I take such that sine 2x is half. So once again, you are going to do the similar procedure. You're going to locate the quadrant. So okay, so sine is half, so positive. So it is in quadrant number 1, that is here or here. Now here the problem is that you see the differences. So this was x and here it is 2x. So the thing is that here first we're going to solve for 2x. So okay, 2x is sine inverse of half. So there is not only one answer, like you could see that there was more than one answer. So is here. Sine inverse half, sometimes students write 30 degrees and they forget about it. So first thing what you're going to do is that since the range of x value is 0 to 360, we will first solve for 2x. So what we'll look at is between 0 to 720 is the range of x values, 2x values. So my first angle is here. If I do sine inverse, now since sine was positive here, the sine inverse of half that I take is positive. This is positive 30 degrees here. This is 30 degrees here, base angle. Now you're going to measure the x value. So 2x, I will first go from 0 to 360. The first angle is 30 degrees, you can see. The next angle is 150. Now we have to finish one rotation. So we notice that one rotation, we got two solutions. Now next solution will be after 360. So 360 plus 30, which is 390. Then again 360 plus 150, 360 plus 150, which is 510. Now these are the x values. So what you're going to do is you're going to divide each of them because you have to go over to 720. That's why you took two rotations. So in two rotations, you've got four solutions. Then now you got to divide each answer by 2. So 30 divided by 2 is 15, 150 divided by 2, 390 divided by 2, and 510 divided by 2. So whatever the answer you get, That will be the answer for x value. Now let's take one more example, that is this second example, which is we have to solve that 5 cos 2y minus 4 sine 2y is equals to 0, where y is equal to 0 to 180. So this might seem a little difficult in the beginning, but actually these are like all super easy questions. Now here what we do is we are obviously going to do some operations. So 5 cos 2y equals to 4 sine 2y. We're going to do that. Now then what you do is you just bring 4 here. So 5 over 4 equals to tan sine 2y over cos 2y. So I'm just bringing it down here. And this I'm trying to basically get is the tan 2y is 5 over 4. So the value of tan 2y is 5 over 4. And the range of y value that we're looking is 0 to 180. So first we're going to solve for 2y, which is, and here just clarity in case you didn't understand how I got from here to here. The tan 2 theta will be, as you know that it is sine 2 theta over cos 2 theta. So that's the use I made here, the identity. So now if y is between 0 to 180, so 2y, first you solve for 2y, which will be between 0 to 360. Now step number 2 is to locate which quadrant your possible angle is. Now if you see that here, ASTC, since my ratio is positive, like let's say 5 or 4, what you do is that you take that this is the possible position, first quadrant or third quadrant, because these are the positions where the ratio is positive. Now the next step is to find out the base angle, these two angles. So once you get that, you're going to do this step. 2y is nothing but sine inverse of 5 over 4. So here the first thing that we got is that, okay, so tan 2y or tan 2y equals to 5 over 4. This is what we had got. So now the first thing is that since the ratio is positive, you're going to use the ASTC rule, all sine positive, tan positive, and cos positive. So here your possible angle, because tan is positive, so these are the two positions. Now what you're going to do is, now you first use this base angle, like use this basic ratio. So 2y is tan inverse of 5 or 4. You could just use a calculator, which will basically this angle, if you find out in calc, will be 51.34. So that's your this angle, and similarly this angle will be 51.34 as well. Now, since the range of y value is 0 to 180, so 2y value will be 0 to 360. So we're going to look at, first we are solving for 2y, so we'll go from 0 to 360. So first angle that you notice here, the 2y is nothing but 51.34. That's 51.34. That's one angle. The next angle is this one, which is 180 plus 51.34. So 180 plus 51.34, which is 231.34. So now this is the value for y. Now if you divide y value by 2, I mean this value is by 2, you'll get the exact value of y. So 51.34 divided by 2, then you got 231.34 divided by 2. The answer is 25.7 and 115.7. So these are the two values fall well within 0 to 180. So these kind of questions are generally asked in the additional math exam as well as math standard and higher level. So the next type is one of the questions that involves some quadratic equation solving. So here the question is 2 cot square x minus 5 cosec x minus 1 is 0. So let's say 2 cot square x minus 5 cosec x minus 1 equals to 0. Now here what you notice is that we are linking up two terms, cot x and cosec x, which we have an identity for. So we're going to just quickly use 1 plus cot square x equals to cosec square x. So in place of cot squared x, we could put as cosec squared x minus 1. So if I do that, what we get is, I'm just trying to get the entire equation in terms of cosec x so that we can solve it like a quadratic. So it'll be 2 times cosec squared x minus 1 minus 5 cosec x minus 1 is 0. Now you open up the bracket, what you get is 2 cosec squared x minus 2 minus 5 cosec x minus 1 equals to 0. So what you get is eventually 2 cosec squared x minus 5 cosec x minus 3 equals to 0. So now we get this quadratic. What we do is we're going to take let cosec x be y. So you get 2y squared minus 5y minus 3 equals 0. The reason to convert in cosec was this, that we get every term in terms of cosec so that we can write down as a quadratic equation. Now, when you factor this out, the product of the two numbers should be minus 6 and sum should be minus 5. So it is 2y squared minus 6y plus y minus 3. So you factor this out, 2y, y minus 3 plus 1, y minus 3. So here what we get is eventually you get 2y plus 1 in one bracket and y minus 3 in other bracket. So what you get is y is either negative half or y is either 3. So eventually this results in either, okay, cosec x is negative half. That results in sine x equals to negative 2 because reciprocal of cosec x 1 over sine. And if you reciprocate this, you get sine x equals to negative 2, which is not possible. So this, because sine x value is always between minus 1 and 1, and this is negative 2. So there will not be any x value possible for this. Sine can't be beyond minus 1 and 1 and minus 1. Now, second one is where your sine x, cosec x is 3. So 1 over sine x is 3. So sine x is actually 1/3. Now, since you got sine x is 1/3, we're going to solve for it. So now sine x is 1/3. So now you're going to locate the quadrant, which quadrant your angle is going to be. So we see that first quadrant and second quadrant sine is positive. Now you do sine inverse of 1/3 to get this base angle, which is nothing but 19.5. This is also 19.5. But now when you measure the angle, which is between 0 to 180, because I have to measure from 0 to 180, so that's the first angle will be 19.5. So x is 19.5. And the second angle will be this one, which is 180 minus 19.5, which is 160.5. So this is how you solve this kind of question. So while doing this question 2a, we have to be a little bit extra careful because there are some things that come out which is a surprise. So what you do is, let's say 3 sine x equals to negative 4 cos x. Now obviously divide cos x here and 3 here. So it is 3 sine x over cos x equals to negative 4. So sine x over cos x equals to negative 4 over 3. Now, when you're solving for x values, what you do is you have to be very careful. Now, let's say this is nothing but tan x. Now, tan x is negative 4 over 3. So tan is negative. Now, this thing is just going to be used to locate my angle. In what quadrant is my angle? So if you see here, ASTC, so here all and tan is positive, here tan is negative in quadrant 2 and 4. So you are now just going to find out this base angle. Okay, so for base angle, I'm not going to use this minus sign. So for base angle, I'm not going to use this minus sign. So you can simply do tan inverse of 4 over 3, and this is what is that angle. So first let's do tan inverse of 4. So this answer that comes out to be 51.1. That is, this also will be 51.1. Now we go on to actually measure the angle. So when you go on to actually measure the angle, your first angle is going to be this one, which is 180 minus 51.1, which is nothing but 126.9. The second one is the angle which is this one, which is 360 minus 51.1. That is going to be um, nothing but 306.9. So this answer actually is 53.1. This is 53.1. So this comes out to be 126.9 properly, and this is 306.9. So overall, basically now here the general mistake that you do is that you straight away take x is tan inverse of negative 1.33, and you might get the answer as minus 53.1, which is actually this angle taken clockwise. That's fine, but that's not actually the answer that they're looking for. So what you do is you'll follow this method that I did. Actually locate the quadrant, find this base angle. So in that case, you don't need to take tan inverse of negative, because then you're actually finding the exact answer, which calculator doesn't give in this range. So what you do is you find out just without the minus sign, and then after that you do the general manipulation. So first angle you go is this angle, which is 180 minus 53.1. The second angle is from here all the way to here, that is 360 minus 53.1, that comes to 306.9, and that's how you find out the answers. Okay, so while you're doing this B part here, the second part, it is 6 cos y plus 6 sec y equals to 13. So what you do is you do 6 cos y and try to get in terms of one trig ratio so that we can do substitution. Sec y, as you know, is cos y, so cos y is equals to 13. So let cos y equals to, let's say, t, or let's say cos y be x or something. 6x plus 6 over x equals to 13. That results in 6x squared plus 6 equals to 13. Um, this results in 6x squared plus 6 equals to 13x, and you get 6x squared minus 13x, and plus 6 equals to 0, and you factor this out. So if I factor this out, the product of the two numbers is here is 36, and sum is negative 13, which is 9 and 4. So 6x squared minus 9x minus 4x plus 6 is 0. So you factor it out, so 6x, 3x here, so 2x minus 3 minus 2, if I take here 2x minus 3 is 0. So we get 2x minus 3 and 3x minus 2. So this gives us x is either 3 over 2 or x is either 2 over 3. Now remember that the cos or sine can't exceed 1 or minus 1. So that's what this 3 over 2 actually, which is where it is cos y, can't ever be 3 over 2. Because if you look at the basic cos y graph, it's always between 1 and minus 1. So this is minus 1, this is 1. And they're asking if y equals to 3 by 2 is here. So it is never going to cut this graph. That's why there is no solution to this. And now this cos y is actually 2/3. Cos y is 2/3 now here. So it is basically now you're going to solve for this one. Now where do you see where is cos positive? The cos is actually positive in the quadrant number 1 and quadrant number 4. So quadrant number 1 here, that this is the possible, because ASTC if you do, so this is the possible position. Now cos inverse of, so y is actually cos inverse of 2 over 3 when you do, that comes to be somewhere 48.2. So this angle is actually 48.2 and this is 48.2. And now you have to do actual measurement. So when you do actual measurement, it is this angle, which is 48.2. That's your one y value. And the second y value is this angle from here until here. So that is 360 minus 48.2, which is 311.8. So this is how you do this.